Sorry, basically this video is basically a remake of of my last video related to science, but the thing is that this video is in English. So this, if you don't understand Hindi but you understand English, then this video is for you. And uh, or you want to know what I said in my last video and you don't know. So basically this video is very neat because I can speak fluent English but not fluent Hindi because I have been living in an English country for like 10 years. Yeah. So this is how you balance a chemical formula. Let me just write that down. Chemical equation. Sorry, how do you spell equation? Yeah, this is an example. Okay, so sorry, according to the example, also let me just yeah, yeah, I'm actually good at computing, so yeah, let me just write down. First of all, differentiate the number of elements, pure atom, a pure atom, the numbers of pure atom. Look for how many types of pure atoms are there. In this case, there is one carbon, the second hydrogen, and the third one oxygen. So what you want to do is you want to write out. No, actually, you want to draw a line. In my method, you want to where is it? You want to do one thing first, which is draw a line which aligns with the arrow, but in this case there's no arrow. Well, there can be, but I don't want it because it looks ugly. So you want to differentiate these two parts, and you wanna write out C, which stands for carbon, and write out how many atoms there are in this side here. Obviously you're gonna write this one here and the amount of atoms in here, but oh sorry, let me just yeah. So what you wanna do is this again. You first of all look here. Yeah, here this is C. There's nothing behind it in here. Yeah, there's nothing behind it there, but that means there's one here, and then there's a small one. Where is it? Change it to around 1. Yeah, there's a small one here. So that tells me that, and if there's something like this, these two numbers are to be multiplied. 1 times 1 is 1, so I'm gonna write here 1. And let me just take that out again, because I want to show you another example so you can understand it literally. And then to say if you want to do the same to the H4, I already have H and what do you say, a 4 here. Yeah, I already have, sorry guys, I already have a 4 here. Or use, sorry, I already let me just write a 4 here. Yeah, I already have a 4 here, so that, and there's nothing here, so that must mean that there's a 1 here. So 4 times 1, what's 4 times 1? It's H stands for, oh my goodness, someone kill me. H stands for hydrogen, and how many hydrogen atoms there are? 4 times 1 is 4. For this side of the equations. Now let's look at oxygen. Oxygen, there's nothing here, but there's a 2 here. That means there's 1 here. So 1 times 2 times 1 is obviously 2. So there's one carbon atom, 4 hydrogen atoms, and 2 oxygen atoms in this part of the equations. And if you follow the law of conservation of mass, that means that the amount of mass in this side of the equation must be the same as this side of the equations. As you would say, the results, the products. So now let me do the same. Let me count out the atoms. Let me just disable that and then take this out. Yeah. Now you wanna write C. It's just too big. Sorry. Yeah. Nah, that's better. Can you see it though? Oh no. So I'm gonna make it a little bigger. Yeah, this is nice. Yeah. C. So you see one C here. There's nothing in front of it. There's nothing behind it. So you wanna write one and a one here. Yeah, yeah, that's gonna be one again. Why is that enabled? So now H hydrogen atoms. There is only two here, and there's a two in front of it, and there's nothing behind it. So we'll take it as one. One times two is two, and then if you look at oxygen atoms, there's one oxygen atom here, and be careful, this two only counts for the one next to it, for the one to the left of it, and this is supposed to be smaller. Sorry, this is supposed to be smaller like that. Yeah, the smaller ones only represent the one next to it, and this the one which should be here even represent this one. So I was at, yeah, if there's like a 2 here, it means that, and if you want to get this one, what you have to do is this 2, the number here, and if there's nothing here, it means 1 times the number that's here, and there's nothing here, that means 1 as well. So I want to remove that for the second. I'm not for the second. Remove that. Yeah. So yeah, oxygen. There's one here because there's nothing there, and there's one here because there's nothing there. It's the same, vice versa. So well, I was at, yeah. Now oxygen, yeah. Oxygen. There's one atom here, and then there's two atom here because there's O2 and there's nothing here, so that means 1. 2 times 1 is 2, and then plus 1 is 3. So there's going to be 3 atoms here, and yeah. So now what you have to look for is the differences. For example, the difference is there's no difference in this part, so you leave it, but there's difference in this part and this part. So what you want to do is you want to look at if they are least common. No, not what do you want to look at? Yeah, what you want to look at is like this times, can anything times by this can equal to this, and in this case there is 2 times 2 is 4, so 2, and then I'm just going to put a 2 here. Yeah, 2 times 2. Look now, just like what I said before, there's 2 here, so that means there's going to be a big 2 here, 2, and there's 1 here, so that's gonna make it 2 oxygen atoms plus another 2, which is gonna make this one 4, and this one 4 as well. Now we made this. We have to make this the same. Now we made these two we never made this the same, but we made this one the same. Now we have to make this one the same, and this one is different here, and I can times it by 2 to make it this quantity. 2, this oxygen is here, and this is not gonna change this, so basically that's it. 2 times 2 times, I have to make it this small. Yeah, that's better. Two. Let's just make it right. What it should look like. Now even this. Yeah, this is how it should really look like. Now we have made this 4 because on this side there's 2 times 2, so that's gonna make it 4. So that's how you balance a chemical equation. You can't just say there's like, you can't just say like there's like an atom flew away into the void. Yeah, you can't say that, because if a equation slash a reaction take place, then the mass O slash the number of atoms in each single thing, the reactants and the products, both of the masses slash the number of atoms in it must be same, because atoms can neither be created slash destroyed. They can either be split slash uh split from the world to be used, or for oricum compound to make energy. So that's it for today's video. Sorry for any interruptions if you feel so, if there are any, because I certainly do not feel any. So that's how you balance chemical equations slash reactions. And in the next video I'm gonna make a video about a gaming video in English. Okay, so the game is gonna, in that video I'm gonna do a challenge, a trending challenge in GTA 5. So that's how you get subscribers. Joking. Bye.